The fitness guru and television personality Jack LaLanne once said, "If you've got a big gut and you start doing sit-ups, you're going to get bigger because you build up the muscle. You've got to get rid of that fat. How do you get rid of fat? By changing your diet."
Welcome to the A&P Professor. A few minutes to focus on teaching human anatomy and physiology with host Kevin Patton.
In this episode, we'll have updates regarding the cerebellum, liver, and body weight, then a discussion of how understanding muscle names helps students learn. For a long time, we've all been teaching that the cerebellum's job is to help coordinate muscle movements. Scientists first learned this when we saw that when the cerebellum is damaged, it impairs the process of planning and executing a variety of body movements. Now, calm down. Neuroscientists are still on board with this story. However, over the last few decades, we've seen at least two changes to the last best story of the functions of the cerebellum. One is that we're learning a lot more about all the complex mechanisms involved in how the cerebellum functions in partnership with the cerebrum to plan and execute movements. For example, some recent experimentation is showing that the cerebellum has a big impact on memory, specifically the memory needed for effective motor planning. Well, that makes sense, right? Because as we learn a movement, like how to bat a tomato thrown at us by a student out of the air before it splats on our face, we have to try and fail a few times before we're good at it. Each time we try that movement, we remember, or our cerebrum team remembers, each exact instruction involved in the motor programming. When we bat at that next thrown rotten tomato, we probably do a little better because our cerebellum is making corrections based on the memory of what happened the last time. A few more rotten tomatoes and we can bat them out of the air accurately every single time, giving it barely a thought. At least I can. That's because I've had a lot of practice. That's because the cerebellum is using memories of failures to adjust the motor programs that coordinate our movements. These recent experiments I mentioned are confirming that the cerebellum is somehow involved directly in the memory activity, not simply getting the memories from the cerebrum. This is a bit more than we've been giving the cerebellum credit for, right? There's also some evidence that this carries through to slower, more thought-out movements. That is, movements that require consideration and strategizing, like moving chess pieces around on a chessboard. I don't think we can support that idea fully at this point, but this is where the science is taking us, so stay tuned. Another thing that's been going on with our evolving story of the cerebellum is that, well, it's not just for coordinating movements. Think about it. The cerebellum has somewhere around half the total number of neurons in the brain. And yeah, motor coordination is going to need a lot of neural processing. But maybe it's not so surprising that there's more going on in there too, right? With all those neurons. Over the last few decades, we've seen a variety of additional cerebellar functions demonstrated. For example, it seems to have roles in abstract reasoning, in regulation of emotions, in social interactions, in our brain's reward system, all kinds of things. We've also seen that besides direct communication with the motor cortex, the cerebellum also communicates directly with other areas of the cortex, with the cerebral nuclei, or basal ganglia, if you prefer that, and connections with nuclei in the midbrain and other areas of the brain. Because of these discoveries, we're now learning more about the possible additional mechanisms involved in things like addiction, autism, and even decision-making. What's becoming clear is that the cerebellum has a wider range of function than we used to realize. Our last best story is getting more and more accurate. So how do we handle that in our A&P course? One way is to pay attention to what each new edition of our textbooks are saying. They're gradually evolving their stories to keep up. What I do is use an analogy, one that fits well with the linkage between the names and functions of the cerebrum and cerebellum. Remember that cerebrum means brain and cerebellum means little brain. So it's sort of like the cerebellum is a sidekick to the cerebrum in a way. I tell my students that it might be useful to think about the cerebellum as the executive assistant to the cerebrum, a sort of chief of staff, always in communication with the cerebrum, but also in communication with other parts of the brain, coordinating a wide variety of functions and perhaps even doing a bit of decision-making. As time goes by, that analogy may give way to a better one as we learn more about the cerebellum. It's just a matter of what the next last best story of the cerebellum will be. This podcast is sponsored by HAPS, the Human Anatomy and Physiology Society, promoting excellence in the teaching of human anatomy and physiology for over 30 years. Go visit HAPS at theapprofessor.org/HAPS. That's HAPS. And I'll see you at the next HAPS conference. We all know that seeing food, hearing about food, talking about food, like donuts, for example, or apple fritters, for example, as I'm doing right now, can trigger a set of neural and hormonal responses that get our digestive tract ready for that food, for those donuts. You know, just in case those donuts I'm thinking about right now actually appear in my hand and then get eaten. Then my saliva will be ready, waiting to greet that donut, and my stomach will have some gastric juice waiting too. And that rumbling I feel, oh yeah, the stomach is getting into its churning up some donuts gear, right? Well, a study that came out a few months ago is suggesting that there's a lot more going on than we thought. It seems that darn donut is also triggering some neurons that signal the liver. Neurons that we used to think only kicked in later on, after a meal, or at least later in a meal of donuts and apple fritters in this case. These neurons, called POMC neurons, signal sympathetic pathways to the liver to get things ready for what happens after the meal. That is, to get ready to deal with the nutrients absorbed into the blood after a meal. The hepatic cells, in response, start switching on genes, making proteins, and expanding their endoplasmic reticulum in anticipation of all the work the liver will be doing during the absorptive state after a meal to deal with the carbs and fats and so on that we're getting from our meal of donuts. So we're not just getting ready for the first part of dealing with a meal. We're also getting ready for the storing the nutrients stage that happens after a meal. And all just because you saw some donuts in the window of a donut shop. A searchable transcript and captions for the audiogram of this episode are funded by AAA, the American Association of Anatomists, at anatomy.org. Hey, another edition of Anatomical Sciences Education just came out. Have you seen it yet? Honestly, I'm very hesitant to bring up this next topic because it's a real can of worms. Not only are there controversial aspects that can profoundly affect the lives of individuals and the choices they make and the attitudes they have, but it's something that we science educators think we know something about, but we don't really know much at all. It's something that scientists working in this area don't know much about either, even though it sounds like they know what they're talking about. What topic is it? It's the relationship of exercise, diet, metabolism, and body weight. Yeah, that. Once you get me started talking about almost any topic, it's hard to shut me up. But this topic especially. So if you're listening to this episode and it's less than 3 hours long, that means I must have gone back and edited out most of what I said. What got me to thinking about this topic is that I once again noticed the usual flow of the confusing, incomplete, and sometimes contradictory articles about exercise, diet, metabolism, and body weight. And also the fact that this week I had my annual physical, during which my doctor congratulated me on the fact that my body mass index, or BMI, is not in the obese range. Yay! Unlike most of his other male patients my age. One of the articles I ran across recently talks about some research that seems to show that exercising more won't help you burn more calories. As soon as I read that headline, I stepped off my treadmill to finish the article, which describes a study on hunter-gatherers who apparently hunt and gather all day long, but don't burn any more calories than a typical Western commuter who goes into work to sit at a desk all day. Why? Well, because our bodies adapt. It's not a simple matter of exercise more, burn more calories. There are all kinds of genetic, metabolic, hormonal, neural, and possibly even magical things that are happening in our bodies to regulate our internal environments in ways that maintain long-term stability, no matter what we're doing or not doing today or this week. Another article I ran across deals with the notion that healthy, thin people have faster metabolic rates than average. I mean, this is a common notion, right? Well, a recent study seems to debunk this idea and instead give more weight, forgive the pun, gives more weight to genetics. That is, maybe thin people who seem to maintain a low weight, even when they do or don't do the things that make me gain weight, they don't have a different metabolic rate than me overall. Maybe they just don't have the genes that are telling my body to store more fat and turn my six-pack into a keg. Study after study is turning our ideas about the relationship of exercise, diet, metabolism, and body weight upside down and inside out, and then back again. So how do we, as A&P teachers, deal with it? The answer is, I don't know. I mean, that's my answer. But come on, I have to have some kind of answer, right? I can't just skip over that part of my course, can I? I'm here to tell you, yes, you can. But I don't suggest that. No, please do not skip over that part of your course. But I will tell you what I do. I'm not saying it's the best thing to do, but I'm just sharing what I do, and you can do with that what you want. I simply tell my students that we're entering into an area where the story is not very clear yet. That while I usually try to stick to the last best story about any topic we cover, maybe it's useful to recognize that the best I can do is tell them the last conflicted, muddy story. You know, the kind of story you get in the occasional novel in which nothing gets resolved, nothing comes together, and you're just left sitting there scratching your head and wondering why you just spent 20 hours slogging through this story. So I stick to the mainstream story, all the while pointing out that it's all being questioned right now. Yes, some folks think that body mass index is an important health indicator and represents something important. And that includes nearly all primary care providers these days. But maybe it's not. Students need to know about it because they're going to encounter it. We can't let them out of our course not knowing what BMI is or what it represents or how it's calculated or how it's used. But they also need to know that this part of the story will likely change soon. It is changing already. Perhaps it'll be completely ripped out of the story before too long. But right now, they need to know what it is. And yes, some folks still think that counting the calorie intake listed for different foods we eat and the burned calories listed for the exercises we do are the beginning and end of the story of body weight and metabolism. So we should be aware of that concept because people are using it, right? But we should also mention that this is a far from complete picture of what's happening in our bodies. There are all kinds of footnotes to it. I can't say that the number of calories my diet book lists for this donut I'm about to eat will actually be available to my cells for use or storage. I can't say that the miles I walk or stairs I climb today will burn X number of calories in my body today. I can't even say that my fitness tracker is really reporting my overall activity in any kind of useful way. So I give them the basics, throw in some questions and challenges, and then I step back and marvel at how complex the real story of our body metabolism must really be, and how fascinating it is to continue to follow the experimentation and debates and fistfights as scientists slowly unravel and then knit back together and then unravel again the full and true story. Of course, the upside to the existing deep mysteries of the relationship of exercise, diet, metabolism, and body weight is that I can expect to have reasonable success with my new book called Kevin's Walking Slowly Then Sitting Down Donut Diet, without anyone having much of a chance of challenging it with scientific evidence. As a matter of fact, I can probably find a whole bunch of articles that would support a central idea like that. So look for it on Amazon or your favorite booksellers starting next week. Distribution of this podcast is sponsored by the Master of Science in Human Anatomy and Physiology Instruction, the HAPI degree. Looking to power up your game in teaching A&P? Well, check out this online graduate program at nycc.edu/HAPI, that's HAPI, or click the link in the show notes or episode page. Learning muscles is hard for most A&P students. There's a lot to learn, and students can be intimidated. So they're not exactly starting off on the right track. One thing that intimidates them is the oddness of muscle names. Now, yeah, it's true. They know a few partial names like biceps, quads, hamstrings, traps, lats. But even so, they know only a few. And the name they know really has no specific meaning for them. I mean, what about the term lat describes that muscle? Okay, maybe once they think about it, already having learned some basic anatomy in our course, they can work out that lat and lateral are connected, and maybe they can figure it out from there. But how far does just a few of those really get us? An idea I've alluded to before is that the language of A&P is important. At least that's my perspective. And when I'm teaching my class, well, it's my class, and that's where I take it. And it's worked pretty well for my students, and for me as an anatomy learner. And this is my podcast, so that's where I'm going to take it, at least for this discussion. If I visit an area of the world where the language is unfamiliar to me, and I've done that, it seems even more foreign in a lot of different ways, and it's pretty intimidating trying to get around or just find some lunch. But if I have at least some familiarity with the language, then I feel more comfortable and I do much better navigating my way in a new place, in a new culture. So one of the first things I tell my students starting a class with me is try to familiarize yourself with the language of each new topic as one of your first steps before even starting to dive into that new topic. And that process, that approach, that attitude works especially well with muscles, I think. Why does it work so well with muscles? Well, because the name of a muscle often tells you a lot about that muscle that makes it different from other muscles. I mean, that's how it got its name after all, right? It was named for some characteristic that muscle has. But if you're not paying attention to the name and just hearing it as an odd combination of syllables and leaving it at that, it's going to be harder to learn. That weird name, that huge collection of weird names, becomes an unnecessary barrier to learning all about muscles. Something else about this approach to learning muscles is that if you pay attention to the meaning of the names, that in itself becomes a mnemonic device, right? A mnemonic device is a memory aid. And if you know the meaning of a muscle name, that automatically becomes a way of remembering at least the characteristic for which the muscle was named. If you remember that an extensor muscle extends apart and you're looking at the upper extremity, you can at least figure out which side of the forearm to look at, right? To try and find that muscle. As with any mnemonic device, if you can remember any little thing about the object you're trying to remember, that little thing usually triggers the rest of the memories you have about that thing. So remembering that one thing about an extensor muscle is likely to give you everything you need by triggering that part of your memory bank, making retrieval easier for you. So what I'm saying is that muscles have their own built-in mnemonic triggers that our students often don't know about, and therefore it can't help them. I'm encouraging us to go ahead and tell our students about this and get them started looking at muscle names that way as helps rather than hindrances. Now, I know what's going through your head right now. Okay, how exactly would I do that in my course with my students? Well, I can't answer that for you, but I can tell you how I do it, and that might spark some ideas. As always, when your ideas get sparked or when you realize you've been doing this all along, but in a different way than I do it, I invite you to share that with our other listeners. Just call the podcast hotline and tell us about it. As I've said, the first thing I do is way back at the beginning of the course, I tell them how important the meanings, the translations of terms in A&P really are. I encourage them to pay attention to that. And if I keep reminding them at intervals, then it won't seem so odd when we get to muscles and I bring it up again. And then when we start muscles, I make sure that I have a couple of muscle models or at least a big torso model that has lots of big muscles visible. They're with me. And an articulated skeleton. That's helpful too. Then I throw out a couple of muscle names that are easy to translate. For example, adductor magnus. Then I tell them that it's in the thigh, and I ask them what might help us find it. For example, I might ask them, what does an adductor do? And we can talk about what adduction is. And then I might ask them, well, which side of the thigh would it have to be on to do that? And that gets them thinking about how muscles work, that they're pulling on parts of the skeleton and so on. And then I ask them, well, what does magnus mean? Well, I mean, that's similar to its meaning in English, right? And so we eventually get to, maybe with a little prodding sometimes, that it means great. So which of these medial thigh muscles is greater than the others? So I kind of, lead them along a little bit, kind of a logical progression there so they can start to see how helpful the muscle name is. Or another example might be pectoralis major. And pect means chest, which I might have to tease out of them Maybe, sometimes I'll say, well, does anybody know where the pectoral fins in a fish are? So that will lead them to the chest area. And then the major part, well, that's easy because, again, that's similar to what's in English. And so then I point out the pectoralis minor to contrast with the pectoralis major, and we're starting to get it even more now. Of course, I have to make sure that I have a model that's going to show a pectoralis minor on it in order for that to work. Then I mention a couple of principles that'll help them. The first one is they're Latin. Well, of course they're Latin. All of these terms that we use in A&P are Latin. But what it means with muscle names is they're going to all have Latin endings. And there's a large variety of Latin endings. And those endings may help somebody figure out whether that word is a noun or an adjective form. But it's the root that we're mainly interested in. So that's what I encourage my students to focus on, is the root of that word. But speaking of nouns and adjectives, there are some things that might help clarify the naming of muscles. Keep in mind that in Latin, the noun generally comes first and the adjective modifying it comes next. That's the opposite of English. In English, we might say little red wagon, but in Latin, we'd say wagon red little. Now, the primary noun in all muscle names is the word muscle. Muscle is part of the name, but we often skip that, especially when we're studying muscles, exploring muscles. We just kind of leave that off because we kind of already know what we're talking about. This is an area where we usually mix up the Latin and English format or syntax. So when we're anglicizing the term, we kind of flip it around. If we use the pure Latin format or Latin syntax, then muscle goes first. And actually, if we're really sticking to the pure Latin, we wouldn't use the word muscle. We'd use musculi or musculus. But we do usually anglicize it, so we put the word muscle last. So it would be sartorius muscle. And also, we often abbreviate the muscle. If we're going to use it at all, we often abbreviate it as either a capital M or a small m, sometimes with a period after it, sometimes not. But we usually just skip it entirely and leave off the word muscle because, hey, we're talking about muscles already and we don't really need to keep saying muscle, muscle, muscle. And at this point, I usually mention that we do the very same thing with bones, which they will have just studied before getting to the muscle module in my course. I point to the frontal bone on the skeleton that I said I usually have with me, and I ask, what's the name of this bone? And they say frontal, but I tell them, that's not the name of the bone. What's the name of the bone? And then they get frustrated with me, and I point out that the name of the bone is frontal bone, not frontal, it's frontal bone. Frontal is an adjective that means nothing without a noun to modify it. It's like if I said I lost my yellow. How would anyone know that I meant my pencil? It could be my submarine that I lost, for all they know. But if I'm talking about bones, it's okay to just call it frontal. So that's what we did when we studied the skeleton. We called this frontal and that maxillary and this parietal and so on. If I'm sitting there working in my coloring book with a big pile of pencils and I say I've lost my yellow, well, that's okay too, because now you know that I'm talking about my pencil. So it's context that can, contribute to the meaning of what we say. Of course, we know that, but here's a place where it particularly applies to using anatomical terminology. Now, I don't tell them this to go all Alex Trebek on them and tell them they forgot to put their answer in the form of a question or some other little technicality that makes their answer unacceptable. But I do it to simply let them know how to communicate professionally and accurately, and that it's sometimes okay to use a partial name for something, and sometimes that's just not clear enough to use a partial name. That is, I'm going to emphasize to them that they ought to be aware of the rules of the game. So getting back to muscle names. Muscle is the noun, even if it's not there, and is merely implied by the fact that we're exploring muscles. However, some muscle names do appear to be nouns and not adjectives describing a noun. For example, sartorius. sartorius literally means tailor. And tailor is a noun, right? But in this case, it's used as an adjective. Really, it's sartorius muscle, because remember, muscle is part of the name. So it's the sartorius muscle, not just the sartorius. If we were talking about the sartorius outside the context of anatomy and outside the context of looking at muscles, and we talked about the sartorius, we really could mean a literal person who sews clothing. But since we're talking about muscles, we can just use sartorius as a shorthand form of the full name sartorius muscle. So we would translate that as tailor muscle. So here the noun tailor is used as an adjective. It's describing the muscle. What kind of muscle? It's a tailor muscle. It's like when I use my teacher voice. Teacher is normally a noun, but I'm using it as an adjective to describe the loud enough, clearly enunciated voice I use when I'm in the classroom. You know, that voice we forget to use in a faculty meeting so that people other than those just around us can hear what we're saying. But again, I don't think most students will need to know all of that. But it is good for us to know that, if for no other reason than to help those students who really embrace this method and want to dive deeper into it. Or in case we're competing in the A&P tournament on Jeopardy! I then sort of point out some groups of muscle naming characteristics, like, names that have to do with the size of a muscle, like major and minor and longus and brevis and magnus and minimus and vastus and so on. Or names that have to do with the shape of a muscle, like trapezius and orbicularis and rhomboid and serratus and gracilis, which translates as slender. Or maybe the number of heads that a muscle has, like biceps and triceps and quadriceps. Or the direction of the fibers within a muscle organ, like rectus or oblique or transversus. Or maybe the action of the muscle, like adductor or flexor or extensor. Or the attachments of that muscle to the skeleton. For example, one of my favorites, sternocleidomastoid, just because I like the way that sounds. It has a lot of syllables and just kind of rolls off the tongue, right? Sternocleidomastoid. Or, I mentioned those that have particular unique characteristics, like the sartorius that I just mentioned, the tailor muscle. Or the lumbricals, which are the worm muscles. Or the masseter, which is the chewer muscle. Or the buccinator, which is the trumpeter muscle. Once you know those names, you often don't forget them because they evoke an image of a shape or a size or a trumpeter. And that's what makes them good as mnemonic devices. They really lock it into our memory, or at least lock it in a little bit better than it'd be locked in otherwise. Now, some A&P books give lists or tables or other kinds of helps along these lines so that it's pretty handy for students that are using this kind of approach. And then after that, I give them a few more examples so they can see what I'm doing. Okay, once again, I know what you're thinking. How are my students going to be able to do this on their own? Well, maybe they can't. That's okay. I just want them to know where the names come from and that they do have a meaning that could help them. If they pay attention, maybe they can simply figure out some of them and use the name to their advantage for learning. I use a textbook that has most of the muscle names translated for them, if not in the chapter word lists, then in the glossary. But to make it easier for students, I give them a handout that lists the translation of each muscle name. And you're welcome to use my handout. I have a link to it in the show notes and episode page. The link takes you to my Lion Den website where you have to register, and it's free. Don't worry about that. You register for it, put in your email, and choose a password. And you can download either the PDF or DocX format. If you use the Apple or Android app for this podcast, what I call the TAPP app, then you can access it there too. The handout also has pronunciation guides for each muscle name too. I just updated it a few days ago, so if you've downloaded it before, you may want to do that again so you have the latest version. I also have links to resources that you can point students to from your own course. So you don't have to do any of this in your class. You can have them use the video or web pages on their own instead. And as always, if you have some additional tips along these lines or have reasons why you think this approach may not be a good idea, well then let us know. Hey, don't forget that I always put links in the show notes and at the episode page at theapprofessor.org in case you want to further explore any ideas mentioned in this podcast. And don't forget to call in with your questions, comments, and ideas at the podcast hotline, 1-833-LION-DEN. That's 1-833-546-6336. Or send a message to podcast@theapprofessor.org.
The A&P Professor is hosted by Kevin Patton, professor, blogger, and textbook author in human anatomy and physiology.
This podcast is certified fresh and wholesome. It also has negative calories due to the energy needed for hearing and brain processing.